Okay, so for the transformations part of your Unit 1 test, I'm going to go through a few examples. Remember that your Unit 1 test is going to be multiple choice, so you won't be expected to graph these transformations on your own, but you are going to be expected to identify them. But we'll go through a few examples and then I'll elaborate a little bit further. So this one wants me to graph the function g as a reflection of the function f across the x-axis. So my function f is my original function, and it is plotted in blue. I'm going to plot the function g in red. So if we're looking at number 13, if I'm doing a reflection across the x-axis, that means that I want to flip my graph over the x-axis. So all that I need to do is make my y coordinates negative. So this one has a coordinate point of 3, 1. If I'm flipping this across the x-axis, all I have to do is make my 1 negative and keep my 3 the same. The coordinate point, this one is 2, 0. Can't make 0 negative, so I'm going to leave that alone. This coordinate point is 1, 1. So I'm going to make this 1, negative 1. So once you hit about 3 points, you can kind of see the trend and you can just carry it on. And this is a reflection of my function across the x-axis. Now, if I'm going across the y-axis, I'm going to make my x values negative. So this point right here is 5. When I reflect it across the y-axis, this 5 is going to become a negative 5. So I'm going to end up over here at negative 5, 0. I'll do my next point. Take this one. This point is 3, negative 2. When I reflect it across the x, it's going to become negative 3. Across the y, it's going to become negative 3, negative 2. I'll do this point up here. When I reflect this point across the y, this is going to become, my original point is 0, 1. You can't make 0 negative, so that point just stays where it's at. And then when I do my last point, let me erase these. When I do my last point over here, it is negative 5, negative 1/2. Now it's going to be positive 5, negative 1/2. Okay. And now I just go through and connect the points that I transformed. Okay. And that graph in red is the translation of f across the y-axis. All right. Now for number 16, it says graph the function that is a vertical stretch by a factor of 3.5 of the parent function f of x equals absolute value of x. Now, remember that on your chapter 1 test, you guys aren't going to be expected to graph this by hand. However, you are going to be expected to be able to identify vertical stretches and compressions, or horizontal compressions and stretches. So, to begin, the first thing that I want to do is I want to plot my parent function. The absolute value of x is my parent function. So the absolute value of x this is me plotting my parent function. I don't know why it's doing that, y'all. This is me plotting my parent function. And if I'm going to do a vertical stretch by a factor of 3.5, all that this is telling me to do is multiply my y coordinates by 3.5 and leave my x's alone. Multiply y by 3.5. Okay, so let me take a look at this point down here. This has an x coordinate of 1 and a y coordinate of 1. So when I multiply my y by 3.5, my new point becomes, I'm trying to think, 1, 2, 3, 3.5. It becomes 1, 3.5. 1, 3.5. So this new point is 1, 3.5. All right, when I go over here, this point is negative 1, 1. When I multiply my y by 3.5, I move up. And now my new point is negative 1, 3.5. And then I'll do my point at the origin. You know that this point is 0, 0. If I multiply 0 by 3.5, I end up with 0. So now that I've graphed 3, I can kind of just draw. We'll connect my dots. And that's it. That is the function, the absolute value of x vertically stretched by a factor of 3.5. That's how you do that. Okay. And the next thing that we are going to cover are our piecewise functions. So let me copy this graph real quick.